Hi friends, in this tutorial I'm going through PySpark. So as you know, PySpark is a programming language which will help you to do all the ETL jobs. So if you have a data lake, or if you are using the data AWS Glue, or if you are using Databricks, so basically you are working on the Spark platform, and when your data is stored in Spark cluster, which is basically a distributed clustering, you need how to work on that data. For that you need a PySpark language. Okay, and this tutorial is fully hands-on based tutorial. I have created a Jupyter notebook for you, so that we will go through each and every detail, more detail. Okay, so this tutorial will be available in GitHub. It's already there, and I will also share the GitHub link in the description. Okay, so the first step is, because I'm running this locally, not in any cloud platform, we have to install and import PySpark. Okay, so these are just basic commands. You can just execute it. Okay, so, and remember, since you are installing them locally, you can create a virtual environment. So I have created a virtual environment over here, and all the Spark related installations are over here. So the advantage of having the virtual environment is you will have one environment where all the libraries will be sitting over there, and they will not be conflicting with your system library. So I'm using, suppose, Mac, and in the Mac I have different version of the Python, and then I will have different version of other libraries. Okay, so I don't want to conflict anything with that, so I installed all the libraries whatever is needed in virtual environment. Okay, hope it's clear. So these are the few imports. Let's go through one by one. Okay, so the important thing is Spark session, which will basically help you to create a Spark object. Okay, and then some functions, like these are the functions we will go through. These are the aggregate function, count, sum, average, max, min, and some other functions related to date and time functions you can see over here. And other function is a window function. We will go through each function one by one. Okay, so let's run this cell. Initialize Spark session. Okay, this is initializing and creating the Spark session object. Okay, so this particular one line of code, you will find it everywhere. Spark session dot builder, and application name master config getter create. Okay, it's a standard code, just run it. Okay, so you can see Spark version 4.0 is installed. Okay, now the next thing is, here we are using a data. Okay, and data is this CSV file. Okay, sample employee.csv file. Okay, let me open this CSV file. Okay, so it's a very simple file. As you know, Spark can handle large amount of data. Okay, so we do not want to, like, we just want to learn the concept over here. So we will go through only with the sample file. Okay, so this file has got like employee ID, name, department, salary, age, joining date, and location, and just 20 rows of the data. Okay, so when you work on a data, especially the data is in the form of the CSV. Okay, so it's basically, we can say, as a two-dimensional data. Okay, and it's always good to use the data frame. Okay, one question, always remember, this is Spark data frame, not the Panda data frame. Okay, so the methods which you use in Panda data frame are not applicable over here in Spark data frame. Okay, so first is you have to load this data. So you created the Spark object in the last here. Okay, and then come over here, spark.read.csv, sample employee csv, header true, infer schema equal to true. Okay, and you see data loaded successfully. Okay, now let's see the basic data frame operation. So one of the basic operation which if the data is loaded, we want to see the structure of the data. We want to see the schema of the data, like how many columns are there, how many rows are there, and each column, what is the data type of each column, whether it's a string, whether it's integer. And then we may also want to see for each column, if it is applicable, what is the average value, what is the minimum value, what is the max value, right? So it will give us the overall idea about our data. Okay, so let's come over here. So what we did here, first I am just checking the first 5 rows of the data. Okay, df.show. Okay, so data frame which we have created after loading the data. One thing remember, okay, in Panda data frame I am just converting to Panda data frame also, because many of you would have worked in definitely Pandas. Okay, and there you just write a df and it will print like df.head, or you just write the df, it will print the whole data frame. Okay, here in Spark data frame, you have to, if you want to show the data, okay, you have to always use the show method. Okay, and then 5 is like how many records you want to show over here. Okay, so here if you see df.show and df.columns, df.columns method is used to show all the columns which we are having it. Okay, if you run it here, you can see here, this is the first 5 rows of our data: employee ID, name, department, salary, age, joining date, location. Nicely put it over here, and then this is our columns. Okay, so now let's come to next here, display schema. Okay, I want to see the schema, means what are the columns are there and what is the data type of each column. Okay, so df.print schema, run this. So here you can see these are the columns and these are the integer string. It will nicely, it says about this column. Okay, now another method is very important which I am going to show you, that is the describe method. What this describe method does, it will give you the statistical summary of numerical columns, as I told you, because it will give us some idea about the data, right? Like salary, what is the min salary, what is the max salary in my data set, right? So now our Excel sheet is very small, like it's just a 20 rows. Even if you just look at it, you will be able to see the min and max values. Okay, but in the real life it's not going to be the same. Okay, your data may be having the million of rows. Okay, so this is basically help you at that point to get the actual overall data. Okay, so remember again, df.describe and .show. So as I told you, the show method, you have to use it always to show the data. Okay, so automatically it will calculate the count, how many count are there in employee ID columns, 20, each 20, because count is not related to whether the columns is integer type or it is a string type. Okay, mean. So if you see wherever we have calculated the mean, the employee ID mean is 110.5. Okay, and same way, because if name is a string type, it's not applicable, so it has automatically put as a null. Okay, and salary mean is $84,200. Okay, and age is 31, and again location is again a string, it has make as a null. Then standard deviation, again for all the integer columns you have calculated standard deviation, and then you have the min and max. Okay, so okay, now let's come to the very important part. So till now we saw the method like df.describe method to show the statistical analysis of my Spark data frame. We saw df.show method to show the actual data frame. We have seen the df.column method to see all the columns, and we have seen the df.print schema method to print the whole schema. Okay, now let's come to the how to select, like you want to select one particular column, okay, or you want to select multiple columns, how to do that. Okay, so we are printing here, print df.select name.show 5. Okay, so what it will do, this data frame will select the name. Okay, df.select is a method to select the columns. Okay, if I want it, I can show you like this here. Okay, I can write it here for you. df.select select. Okay, so here you can give the name of your column. Okay, so whatever column you want to see, suppose I want to see the age column. Okay, so it's very nice nowadays, it will show you everything over here. Okay, and show 5, what it will do, it will list you the first 5 column values. Okay, and run it. Okay, so you can see over here df.select, because since you have used the show method, if you don't use the show method, okay, it is not going to show you the age. Let me put it over here. Okay, so you can see the first age, first 5 ages, 32, 28, 35, 29, 35. Okay, you can see here df.select age, but you can't see over age over here. Okay, so if you want to see any value here, you can just put it here, and if you run it, you will see it over here. Okay, so similar way, here we are putting the name. Okay, print df.select name.show 5, so it will give the first 5 names. Okay, and if you want to use the multiple print, I will just put here print multiple columns. Okay, okay, so here you can see df.select. This is, always remember, the select method is used to select columns. It can be one column or it can be multiple columns, and we are going to use this again and again. Okay, so now we are adding 2 columns, name and salary, and then dot show method to basically show this. Okay, you don't need to use the print. Okay, if you just put over here, it should print too. So I'm just putting it here to have less confusion. And again, so we are just printing name and salary. So you can see over here name and salary, first 5. Okay, so now if I want to add one more column over here, we can add here age, maybe one more column I can add here. You have to see the name of the column, it should be correct. So you can see here name, salary, age and department. We were able to see all 4 columns. Okay, so you learned how to display column values. Okay, so suppose if you want to see here all the employees, their salary is more than 60,000. Okay, so how to do that? So here you selected all the columns. Okay, and in the column you want to put a filter. Okay, so if you want to put a filter, let's do here. So you create a new data frame, df new, df.filter, column salary and greater than 60,000. Okay, and then here you just selected these 2 names. Okay, it's very simple. So what we need to do here, your data frame, put the data frame here. So instead of using the filter select command, you will use the filter, because you want to filter. Okay, and then it putting everything for us, column salary greater than 60,000. Okay, and in the same, because this one will give you the data frame where the salary is 60,000. Okay, now in that data frame, suppose if you want to select name and salary, 2 columns, then you can just add over here. Okay, so let's see what it shows. Okay, I did not comment it out, this one. So you can see over here, it has giving you name, salary and show 5. Okay, so if you don't select these columns, what it will do, it should basically by default it should show you the dot show. Okay, you have to put the show, otherwise without show it will not show you anything. Okay, so now if you run this cell, you can see by default it is showing you the complete table. Okay, so here we learned how to show columns And in the column, if you in a particular column, if you want to give any condition, like in the salary, if you want to filter out with salary less than a range, you can use the filter thing. Okay, now let's come to the new one. Same thing, filter employees with salary greater than 90,000, df dot filter column salary 90,000 dot show. Okay, same thing if you just want to use few columns, suppose only employee and salary, name and salary, so just put here name, salary, or if you want, suppose get as age also, age. Okay, that's it. No, I don't want, just want this one. Okay, it got me department. I just don't want department. So you can see name, salary, age greater than 90,000. Okay, now how to put the multiple conditions. Okay, so you have seen already, you put df dot filter, then in the column where you want to put the condition, you can put greater than or less than condition. If you want to put multiple condition, you just need to use the or and. Okay, conditions. So here engineering employees with salary greater than 90,000, df dot filter department equal to engineering. Okay, column department and column salary is greater than 90,000. Okay, next condition similar way. So here if you see df dot filter, either you can use and put a condition like that, or you can also put df dot where. Both are the same thing. Okay, so here if you see df dot where, we put it here, location is in New York, San Francisco, show. Okay, so if you want to have a condition in string type of data type, okay, so if it is a integer data type, you can easily do the less than or greater than. Okay, but if it is a string type of data type, then you can put you can put the equal here as we are doing it, department equal to engineering, or you can also do over here location dot is in New York and San Francisco. Okay, so hope till now it's clear. Let's go again. Now in this part, we are going to see how to add in a new column and how to modify the existing column. Okay, so here if you see, we have created a new data frame with the existing data frame df, and we are using a method called with columns. Okay, so with column method is used to create a new column. So here we are creating a new column as bonus, and how the bonus is calculated, it is the 10% of the salary. Okay, so the column name and how your column is getting calculated, okay, that you have to, so it's basically column name and the value of the column. Okay, so here if you see, if I just put a show method, if you don't put the show method, df with bonus is not going to show you anything. Okay, so I'm just putting the show method 5, and let's see what it says. So here if you see, it printed the new data frame and with all the column names, and with the new column is bonus, and which is basically the 10% of the salary. You can see it over here. Okay, and this is the new data frame, and again you want to just select 3 columns out of all 6 columns, then name, salary and bonus you selected, and you can see over here it comes name, salary and bonus. Okay, and the third one, what we did it, again we created a new column named as dob, and in the dob we assigned another column value. Okay, so column salary, so you will see over here date of birth will be the same column as the salary column. Now there is one more thing, which is how to change the name of a column. Okay, so here if you see, this is our data frame, and here we have selected a column name, the column name. Okay, and we are using a method called alias. So alias is the method. What it does, it will basically change the name of that column. Okay, so here we change the name of name to employee name. Okay, so the way we give it, like we select the column, and then in the column name itself we will use the method as alias, and we'll give the new column name. So if you run it, and you see here it's changed to employee name. Okay, So here we learned how to add a new column, how to modify the existing column and assign to a new column, and how to change the name of a column. Okay. Let's come to the very important topic here in data frame, and that is the group by and aggregations. Okay, so these are the group by functions are there: count, sum, average, mean. So first understand when we say as a group by what it does. Okay, so if you see your data frame here, in this data frame, suppose we have the salary, okay, or we have the department, and we say as a group by of department what it does. So group by function will basically squeeze your number of rows. Okay, so it will create one row for the engineering, okay, another row for the marketing, and another row for the sales. Okay, so basically these two engineering roles will be grouped. Marketing row will be anyway it's 1, and sales will be 1. Okay, and then it may ask you, okay, give me the group by. You have to basically group by with department and give the salary. Okay, so similar type of questions they can ask. So these are the functions like count, sum, average, mean, min, max, okay, variance. Okay, so here suppose we can get a question. Okay, tell me what is the total number of count of all the employees. Okay, or you can ask what is the average of the salary. Okay, so basically you are clubbing the salary column. Okay, let's come over here. Count total rows and rows per group. Okay, how to count it? So you can simply count here. Total number of employees is basically number of rows, so that you can get it simple df dot count. You will get a total number of employees because it will be employee IDs are there from here to here. And then suppose they can ask you how to what is the employee count with each department. So what you have to do, since you have to find the employee count with each department, you have to do a group by in the department. Okay, so you can see df dot group by and department. Once this, you will get this thing. Okay, then after that you have to use the count. Okay, dot count and show. Let's see what it does. So what it did, your data frame, it has grouped by department. So you can see now you can see only sales, engineering, HR, finance, and marketing. And how many counts are there? 4, 6, 3, 3, 4. Okay, now you want to calculate the salary, the average salary, and grouped by department. Okay, so average salary, you just put a function. So the first thing is you need to remember what you are going to group by. Okay, so group by and that column name. You can either write the column name as department, or you can just write a department. Both are correct. And then after that you put that function which you want to use that. Okay, so hope it's clear. So any group by queries, first you need to see what you have to group. Okay, df dot group by, and then after that you have to see what function you are going to perform. Okay, now same thing, one more time repeating. Sum and average you have grouped with a department, and then you are getting the average. So there are two ways you can write this aggregator function. You group with a department. Either you can directly write this function like average salary, or you can write under the aggregation and average salary dot show. Let's see the third one. It's pretty big. So what we are doing it here, we are grouping with the department, and then we are aggregating. Basically we are getting the salary, the sum of the salary. So if there are suppose 3 departments, what it is going to do, it is going to sum salary of all those 3 departments, and then it is going to change the name because we have the alias as a total salary. And then what it going to do, order by total salary in ascending order. Okay, so starting one will be the lower, and then higher and higher, like that. Okay, so just run it and see. Okay, df.groupBy department, df.groupBy department. Okay, so you have grouped all your department, and then total salary you put it here. So in it just showing you the 2 rows, but there will be more rows. Okay, engineering and HR, and then it has given you the salary in the ascending order. This is the lower and this is the higher. Okay, next thing, similar way you can also apply the min, max and multiple aggregation at once. So the concept will be the same. First you have to group. So here what you did, you group with the location. Okay, and you suppose there is a query in location Chicago, how many employees are there? Okay, so you would have seen you in the location you aggregated, and then count asterisk, you have to use the count function, and then employee count. Okay, you could change the name as a employee count, and when you put the asterisk it will basically get you all the rows. Then average salary alias average, so you created a new one, you just change the name of the column. Okay, salary to average salary, and you just made it as a average. And remember, these all things are grouped by not department, by location. So if you just run it and you see these are the unique location, because you have grouped by Los Angeles, San Francisco, Austin, and then each location what is the average salary, what is the min salary, and what is the max salary. Hope it would be clear. Let's go to the new one. Okay, next function is count distinct and sum distinct. Okay, what it does, number up, suppose it says like what are the, you have to count how many distinct locations are there. Okay, so when you grouped by, what it does, it will basically squeeze all one location in one row, one location in one row, one location in one row. Okay, but here you want to know how many counts are there, so you just aggregate it and use the direct function as a count distinct. So it will it showed you how many distinct locations or cities are there, 8. Okay, and similar way for each location wise how many distinct departments are there, you can get it like this. Okay, same way we discussed about average, mean and median, we can also calculate the standard deviation and variance too. So what we are doing here, we are grouping by the department, and then using the aggregate function, average salary, we change the name to average salary, then standard deviation salary, and then variance salary. Okay, now here if you see what we are doing it, we are returns the first and last value encountered in each group. Okay, so first and last employee name alphabetically per department. How to do that? First thing is what you did, you just ordered as a alphabetically df.order by, and then you grouped them, all of them with the department. Okay, and then each department, like how many people are there, you just need to aggregate with the first name and last name. So here you can see in department it's engineering, and then first name last name, and then it will be with the alphabetical, because you have already put an order by in the name. Okay, these are the few more group by situations. Okay, now let's say talk about this is the aggregation cheat sheet. So these are the functions which I have defined. So the first thing is sorting and ordering the data. Okay, so we already saw the group by. Using the group by, you can group a column values. Okay, and using the order by, you can sort a column value. Okay, so suppose this is the question which is asked from us in interview, and they are saying you have a data frame, basically you have a table, and with this Spark you want to filter top 5 highest paid employees. Okay, so definitely highest paid employees means you have to work on the salary column. Okay, so the first thing what you should do is sort out the salary column in descending order. Okay, so that the first, second, third and fourth and 5 will, like it will be topmost salary to the lower salary. Okay, so that's what we try to do over here. Df data frame dot order by, and then you have done, you took a salary, okay, salary column, and you just put a descending. That's it. Okay, even if you just do this much, it should be able to give you the salary in the descending order in the data frame. Okay, let's do that. Let's see that what it does. Okay, and always remember, you have to use the show method in order to show those so that data frame or employees. Okay, so you can see here top 5 salary, and then here you have employee ID. Okay, now if it says like you have to just find out the employee's name. Okay, so just take this and you can use the remove the show method, and here you can use the select method, because this is a data frame, right? And in this data frame you can always apply the select method, and in the select method you can just put the name. Okay, suppose if you don't want to use the department, you just want name and salary, that's it. And you can see here, oh, you have to go top, so that has got the all, and then you got only name and salary. So these are the employees whose salary is from they are the top 5 highest paid salary. Okay, using the order by, we were able to do that. Okay, so let's see the next question. Sort by multiple columns. Okay, so here we have sorted only in one column. Okay, only the salary column. Now here we will see how to sort with the multiple columns. Okay, so let's see that. So this is your data frame order by, and you put like both of the columns. So what you are trying to do, you want to not only sorting with the employees top 5, but also their department. Okay, so same thing, you in the order by, you just put department and salary both, and salary will be the descending order because department cannot be descending order, right? You just need to group with the department. Okay, department and salary order by, and then simple, because it's a data frame, so you have put a name, department, salary, and so. Okay, so let me see here. So we will get a complete data frame. Okay, I forgot to put the show method. Okay, always remember, put the show method if you want to see the result of data frame. Can you see here? Okay, so here we have got the complete show method, and we can see employee, name, department, salary, age, joining date, and location, and we have sorted with the salary. Okay, so the concept is, if you want to sort with a multiple column in the order by data frame and order by, put all the columns. Okay, and whatever the column you want, ascending or descending order, you can just put a ascending and descending with that column. Okay, so we are good with that. And now the next concept comes, joining between data frames. Okay, so suppose we have 2 data frames, so the question comes, how to join those 2 data frames, right? So you can join 2 data frames, inner join, where the common attribute of those data frame will be joining, right? Then you have the left join, where from the left side it will take all the values and it will join with the right side of the data frame, and then you have the right join. Okay, so first let's create a new data frame, brand new. Okay, so this is your array. Okay, department data, where you have defined engineering, and this is the salary, and this is the budget, and this is the division, which division the department is there. Okay, so engineering department, this much budget, and this is the division, technology division. Same way the marketing department, this is the budget, and then it is the part of the business division. Okay, so here you create a new data frame, spark dot create data frame, department data, you kept it here, and give all the column names. So here you should be able to see the new data frame which we have created. Okay, so this is our new data frame, and if you check our old data frame, what is this? Let me put it here. I cannot put all because it's too many. Okay, so this is our older data frame. Okay, so in these two data frame, which column is the common? Department. Okay, so we will join with the department column. Okay, and then here we will see all three joins: inner join, left join, and right join. So the first is inner join. What it does, it will give you the only matching records. Okay, so in interview you can get such type of problems like there are two tables. Okay, and one is employee table, another one is a department table, and you want to know the employees, okay, and their budget and division. Okay, so basically you will join these two, they will ask you to join these two tables. Okay, so in inner join we will only get the matching records. So how to do that? Here you will use the method join method, df.join, and then first data frame. Okay, df.join your data frame which you have created, and which field you want to make a join, department field and inner. Okay, so basically this much is enough for you to make a join. Okay, so and dot show, if you do, so what it will do, it will give all the common attributes in both of the data frames. Can you see here? So now you have the department, employee ID, name, salary, age, joining date, location, budget and division. Okay, now if you want to select some particular column, so you can just put here dot select, and then whatever you want to say, name, department, salary. If you don't want here budget and division, you can just remove it. Okay, suppose I just want name, department and salary. What happened? Oh, we should not put the show 5 here. Okay, so you got name, department, salary and budget. Okay, so I hope this is clear for you, how to do the join operation and how to do order by. Similar way for left join and right join, this keyword will change. Okay, instead of inner it will be the left join. Okay, the next concept is how to write SQL queries. Okay, so in Spark, so the first thing is what you need to do, your existing data frame you can create a temporary view. Okay, so you can see this is your existing data frame, this is also your existing data frame. You created a temporary view, create or replace temporary view with the employees and departments. Okay, now what you can do, you created this view in terms of employees, in terms of departments. Okay, and now you can create a query thinking like this is a table. Okay, employees is a table and department is also a table. So let's do that. So SQL results is, and remember you have to write the SQL like this, is spark.sql, and select department. Select department. If you just put here count asterisk as this means it's a little complex query. Okay, but basically you can just write the SQL query inside that. So you can see here, if I run in, it's running properly, complex SQL with join. Okay, and if I just want to write a small query, okay, just put it here. Okay, Spark select, I just put here select asterisk from employees E. Okay, that's it. Okay, and let's see what it does. Okay, I just need to do one thing. We have to do the show also, right? So without show it will not work. that was little complex, but here if you see here what we did, I just wrote a Spark SQL inside this. Okay, select, basically I'm just printing the whole employees table. Okay, what is employees table? Employees table is nothing, just a employee data frame, and employee data frame is basically the data which you have loaded, the employee data. Okay, good. So instead of writing the complex like inner join the way we did it over here, if you don't want to remember all these commands or df.join, you can just create a temporary view the way we have created over here. Can you see here? Okay, and when we created a temporary view, we basically got a table, and you can write SQL queries just using this keyword. I hope it is clear to you. Okay, now let's see one more important concept in Spark SQL, and that is the handling the null values. Okay, so suppose if in any column you have the null values, how to show like how many null values are there, how to count it. Okay, so here you can see you use this method null counts, df.select, you are selecting the columns, df.select spark count when column this is null. Okay, for C in df.columns. Okay, so basically what you are trying to do over here is you are selecting a column. Okay, and in that column you are putting a condition whether the column is null or not. Okay, and that one you are renaming as a column C. Okay, so you can see over here. So you will see, so in my table like each column has got the values. Okay, our data set, if you see over here, so everything has got data, so we didn't get any null counts. Okay, now let's come to another, it's a very simple method, so I'm not taking much time over here. Now let's come to very important concept in PySpark, and that's the window function. Okay, so till now you have seen if you want to filter anything in this table, you can filter using the column. You can use the data frame dot filter, you can filter it, you can sort it, you can group also. But what is the window function? Why do we use it? So when we do a grouping of a data frame, okay, so when you do a grouping of the data frame, it will basically squeeze your row. So suppose in my table, if you see here, we have something called as a department. Okay, and we have suppose 5 different types of department, and when you group your data with the department, what it will do, it will create 5 rows, right? Engineering, marketing, it will create 5 unique rows. And then for like with, if you group by department and you want to calculate the sum of the salary in each department, you can apply the sum aggregation function in the salary. Okay, or if you want to calculate the average age in each department, you can group by the department, and then what you can do, you can put a aggregate function over the age. Got it? So here, but the issue happens when you group it, it will reduce the number of rows. But suppose if you have such type of a situation where you want to calculate things in the grouping, but at the same time you do not want to reduce the number of rows, and there only the window function comes in handy. Okay, how windows function will do, it will create a rank for you. So if you see here, when we created when we did the partition, so what we do here, instead of grouping, we say as a partition. Okay, so when you partition with the department, okay, so what it does, it created a new column called as a rank. Okay, and here if you see, all the engineering things came together, and what you did it, you created a rank over here. Okay, unique value 1 2 3 4 5 6. Okay, and then finance also grouped 3 finance 1 2 3. Similar HR only 1 1. Okay, so like that you created a rank, you basically grouped with the engineering, and here your salary is intact, salary in the descending order, and then you created a ranks also. Okay, now somebody says in engineering department, a person who is having the third highest salary, what was his name? So with this way you can easily get it. But if you think like group by, how you will do that? In the group by, definitely you can find out the average salary of the engineering department, right? But in the group by function, you cannot find out the third highest salary of in engineering department, right? So if you want to find out the third highest salary in the engineering department, the easy thing is you can use the window function. You can partition with the department, okay? And same, because you are descending the salary, so you can do that, and then once your rank is there, you can easily figure out who is the guy. Okay, okay, now let's come to more writing data to files. Okay, so how to write your data to the file? So these are the things are there. df.read, we were using df.read.csv, we were using to read the file. Okay, same way, if you want to write the file, df.write.mode and then .csv and give the path of the csv. Okay, similar way, if there is a Parquet file you want to write it, you have to just write df.write.mode and Parquet file format. Okay, so I'm not writing it over here because it will unnecessarily create another dummy copy over there, but this is the way you can write it. Now let's talk about some of the basic string operations, okay, in PySpark, string and date functions. So if you want to create like in a string, like in a column, suppose you have the department column and you want to keep all the department labels in uppercase. Okay, let's see over here what we can do in our sample thing. Okay, or we want to change the name in the uppercase, or we want to change the name, all the name in the lowercase, right? So such type of string operation you can easily perform over here. Let me okay, so df string, you are creating a new data frame with this df dot with column. Df dot with column is basically used to with the column method is used to create a new column. You remember I told you in the previous tutorial, and you are creating a new column here, name upper. Okay, and then this is the value. What is the value you are providing? Upper, and with the name column. So you can see here in this data frame df strings. Okay, let me do one thing, it will be more clear for you. I'm just commenting this and I'm just putting the okay, I'm just putting showing you the complete data frame. So you can see over here the whole data frame here, employee ID, name, department and everything. And here you can see a new column has been created with the name upper. Similar way, a new column has been created with the name lower. Okay, and similar way, new column has to be created with the name, length of the name. Okay, so these are the string, the basic string operation you can perform with and you can create a new column with this. Okay, similar way for the date also, if you want to do these operations, so you have to import these date functions, and then if you want to format your date like in terms of YY, MMDD. Okay, so if you see here joining date, you have formatted in the form of a okay, you join date formatted, you have basically did this YY MMDD. Okay, then join year, if you just want to put as a year. So you just need to remember one thing, with column is used to create a new column. Okay, so these are the new column which you are creating, join date formatted, join year, join month and days employed. Okay, on the right side you are providing the value of that. Okay, now how you are going to provide the value? You are going to use a existing column. that existing column is join date. Okay, now in the existing column you are doing some applying some function. The year function will get the year of the date, month function will give you the month of the date. Okay, and to date function will basically put the date in the YYMMDD format. Okay, and here you are calculating the in the new column days employed is calculating with date difference. So you can see this, we got all these. Okay, now some of the best practices let's go through with the PySpark. Okay, you select early, select only the columns you need to reduce the data transfer. Very important when you work on the PySpark, because in your data frame, suppose in my data frame, right, we have multiple columns here. Okay, but if you keep the whole data frame all the time, right, the problem will happen, it has to use that much memory each and every time. Even we are just interested in the salary column and employee column, right? So think like that, you just want to get the average salary of each department. Okay, now which column you are interested? Only on department and salary, right? So you don't need to keep all the data frame with you. Okay, so remember, whatever the column you are looking for, work with those columns. So what happened, it will release lot of memory for you and your processing will be very fast. Okay, so use select early, use same way, use filter early. Okay, so whenever you think some data is not needed for you, okay, or you may be interested in only few departments, like you just interested on sales and marketing department, then you don't need to carry the whole table with you. Okay, just filter with those departments and keep that data. Okay, avoid collect, don't collect large data frames to the driver. Okay, cache wisely. Okay, so see whatever the things which you want to cache it, maybe you can use it later. Okay, so accordingly you can use the dot cache or dot persist function. Okay, partition properly, choose the right number of partitions for your data size, right? Like in my last thing when we were doing the sorting, I showed you how to do the partition with the department. Okay, use built-in functions rather than creating your own functions, because built-in functions are more optimized. Okay, and monitor your Spark UI jobs. Okay, and this is very important, stop Spark session when it is done. Okay, so these are the 10 best practices. If you do it, your processing will be more fast, it will be more optimized. Okay, again I'm going one by one. Use select operation so that you will work on only those columns which are needed. Use filter in the columns, so you will have only that subset of data rather than the whole data with you. Okay, cache wisely. Okay, because how much cache you are storing, okay, it is storing in your in memory. Okay, and there is a possibility of your in memory data can fill. Okay, so you don't want to cache everything. So partition properly, like how you want to partition your data in terms of date, in terms of department, like how you want to partition, because if you partition properly, the data retrieval will be easy for you. So okay, because it doesn't need to scan through, like if you put any, if you're writing any Spark SQL, right, to query the data, and if you have partition properly, like you have partition in the form of a date. Okay, now you want to fetch information on a particular date. Okay, and you have already partitioned with the date format, then your query will go to exact date and it will fetch the data from there. It is not going to scan your whole data. So that's the importance of partition, that will improve your performance a lot. Okay, use built-in functions so that because they are more memory and performance optimized. Okay, use broadcast for joins with the small tables, and monitor your jobs. Okay, if anything, any alert, any issues comes, take care of that. And always remember, whenever you are doing anything in Spark, always use the Parquet format. Okay, don't ever use the normal CSV format, because Parquet format is a columnar storage, it takes very less space. You try one thing, take a CSV file, maybe it's a 10 MB, and you convert into the Parquet file. It will be just in the KB. Okay, your size is very small, data is the columnar format, and it's very easy to query. So it gives very less resources. It takes very less resources. Okay, and at last, when you finish your job, you stop the PySpark session. Okay. Okay, so I think we are good. We discussed in all these topics. Okay, data frame creation, filtering, selection, aggregations, joins, SQL queries, window functions. Okay, so I think we have covered a lot. If you think any particular topic in Spark you need more understanding, just write down in comments, and I would love to make a video for that. Thank you.